All right, we are recording, so y'all don't act a fool. All right.
Are we going to talk about the test?
What about it?
I don't know, I just thought we would talk about it.
Oh, let's make sure.
What'd you make?
A 93?
Well, you made, hey, you did good.
Yeah. I need to talk to you about one question after class,
Okay.
though.
If you want to talk to me after class, that's fine. Yeah, that's the only thing, because if we talk about what everybody challenges, you never would get through a class. So I'll wait to do that after class, okay? All right. So look at this question right here. Well, before we go over anything, I want you to write down some definitions. And the only reason I want to do this is because we got to review some of this stuff. There we go. Write down some of these definitions in case you... Oh, no, I didn't just do that, did I? Where's undo? Thank God for the undo button. Oh, how did I get rid of... Okay. There. Write down those definitions, and I'll erase this.
Thanks.
We just have to look around it. Causality, correlation, correlation coefficient, slope, and least square regression, because that's what we're going to be talking about. We're going to be talking about regression and the slope and the rate of change. Make sure you put rate of change beside slope, because slope and rate of change is the same thing. Bring in another picture. Still got coughing issue. And we'll put it right there for right now, and in a minute I'll slide it over and get causality, correlation, correlation coefficient, and then I'll slide this over. Now, causality and correlation, that's just something for y'all to have in your notebooks. We're not going to talk about that very much. What we're going to talk mostly about is these things on the right and this blue thing right here. So, okay, I'm going to move this over. Make it a little bit bigger so you can... That's fine. Now, I'll take the blue thing off in just a minute for those that just get the right side over here. Okay, slope. And you don't have to write down the first definition. Write down the second one where it says be inclined from a horizontal or vertical line, slant up or down. And I just want to remind everybody that the slope is the calculated steepness of a line. Okay, because they get that mixed up with regression, and people get that mixed up. And also, which one of those three formulas in the blue look like slope?
Average rate of change.
So make sure you associate rate of change with slope. Okay? That's why you were asking a while ago, you said rate of change was on the last test. Yes, it was on the last test, but it was called slope. All right? And yes, on some of them I did call them rate of change. But I was pulling from other books because this book sucks. So I had to pull from other books, and other books called it rate of change. So, yeah. Do you know how many questions from your test came from this book? I think 5. The rest of them came from calculus books.
Single Valentine's hangover.
What?
Look at the text, the last text that got sent.
Some of these questions. Oh, you mean I missed a test? Yeah, I'm going to send out a test via text. I'd say, what is the slope of the line? That's what I ought to put on number 1. What is the slope of the line? And then I get what line?
Everybody else puts. I got a 93. I'm going to copy her.
Hi.
Probably
That's what y'all
right.
should start doing. The ones in the class, y'all should start saying, what's number 1? Can't see number 1. No, that
a
would
good damn idea, Hubert.
That's pretty good, yeah.
Let's kick him out of the group message.
Yeah, let's do. All right, so here's the slope.
You could do that.
Now, up here, if you look at this, this is the change. Now, some of these questions are going to ask for the change. New minus what? Remember, new minus old. Your most recent number minus your older number. This one, new minus old over old. Multiplied by what? 100. And then, of course, your slope is the last formula. Now, you would be surprised on how many people would take a test in 130 and they know how to do this stuff, but the way the question's worded, the average rate of change, and they just sit there and stare at it because they don't know that it's a slope. And that's one thing that I wanted to show y'all today is these words and these definitions. All they mean is slope, basically. The first one is the change, new minus old. The percentage change is new minus old over old multiplied by 100. And then the average rate of change is nothing but the slope. Now, you're not going to always be able to find this guy right here, okay? Because that is the slope of a line, which is what? Linear. So you're only restricted to linear equations. So if you have a curve, let's say you're in management, business, or accounting, or whatever, marketing, and somebody throws you a curve, what do? Tell them you can't do it and give it back to them? No, you have to use calculus and the form of a regression line. Now, what is a regression line? A regression line is a line that is put to the points that makes the best what? 3 letters. F-I-T. The best
Line
fit.
of best fit.
Yeah. Regression equals line best fit. Usually you're given a scatter plot and you're told to put the line in between the points and to get the best fit. And that's what the regression line is. So you can do all the definitions, but all you have to do is regression line equals line of point plot equals best fit. And I'm going to show you that in here in just a minute. Now, I've already put some things in the Excel spreadsheet, and these are questions out of your book. So if you've got your book, you can easily go to your book and find these, I think. I don't know if I think I took them examples in your book. Now here is, they're giving you, let's see. I think this is temperatures. I'm not sure. Let me look and see. I want to pull it up so you can see the context of the question. There we go. Yeah. Back. There we go. All right, here's the question right here. Now, you can't see it, but I'm going to try to blow it up for you. Does that blow up with y'all? Does that, when I hit that, does it get bigger on y'all's screen?
Yeah.
Easily, it does? Okay.
Yes, sir.
I just wondered because now I can't get it. Hold on a second. All right, I want you to take those numbers and plot them in your calculator. The first number is 0, 0, 49, 1, 58, 2, 66. The time from 7 a.m. Put those in your calculator, and I want you to be able to do this on your calculator. I'm going to do it on the Excel spreadsheet. And then I want you to find the slope between those 2 points. The 2 points given. That's what A says. Calculate the average rate of change. Take average rate of change out and put slope. Between 8 a.m. and 5 p.m. Well, 8 a.m. is 1 hour after 7, and 5 p.m. is 10 hours after 7.
For average rate of change, are we actually writing it out as a decimal? Or
Probably, yeah.
Okay.
Yeah, because you're going to put it in a point slope equation, which means M is going to be equal to a number. But you could leave it. You could leave it as a fraction. It's not going to hurt anything. Just make sure you reduce it.
I just figured we're doing adult math now.
Yeah,
so
you are. Hold your pinky out while you do it.
Yeah.
Okay, Mr. Looney, I'm going to add you. AOLBY?
Yeah.
Now see, I've already got you.
You did?
Okay, I just didn't add you. Yeah, I've already got you, but I don't know why it didn't pull up. Let me go back and find you. Now I'll just update it.
Are you wanting this for that?
You're already in the 130. Well, you're in the 130 Polycom. I saved it again, so next time I send it, you'll probably get it. All right. Now, and most of y'all know how to find the slope. You take which way do we read? Left to right. This is x of 1, y sub 1. This is x of 2. This is y sub 2. First of all, what's the change? The change, and they're going to ask you this, the change is 69 minus 58. 69 minus 58. And what's 69 minus 58?
11.
11. So that's 11 degrees difference in 10 minus 1, 9 hours. 11 degrees in 9 hours. And then you got your percentage change. And if they ask you for and it would be temperature, so that would be new minus old over old. I'm sorry. New minus old over 58. And that'd be what? 11 over 58. Somebody give me that times 100. What does that come out to be? What's 11 over 58 multiplied?
18.97.
So 19 degrees. Okay? I meant 19%. Sorry. 19% increase. Why is it increase? Because it's positive. Okay? So there's your change. There's your percent change. And again, this is just familiarity. This is not hard math, but if you don't know what it is, you just sit there and stare at it. And then, of course, your slope is going to be 69 minus 58 over 10 minus 1, which is going to be 11 over 9.
Yep.
Right? And somebody give me that.
1.2.
1.2, so you got a positive slope. Right there, m is equal to 1.2. Okay, so that's all. Now, what else can you do? Well, now you're going to go into the calculus portion. So we go to this Excel spreadsheet, and for those of you that don't know, I finally figured out, go to, those of you that have a calculator, TI-83 or whatever, go to your calculator and make sure you've got, I think it's called diagnostic on or whatever. Hold on just a second. Go to catalog, go to second 0, and go down to diagnostic, and make sure your diagnostic is turned on. Right there.
Wait, how do I get there again?
Second 0.
Second catalog, or second 0.
And then go down to diagnostic on and hit enter, and then hit enter again, and it should say done. Now, when you do that, and you type in these numbers, and you go to calculate, you got to know what it looks like first. So let me go in, and I'll do this on the, see, I can't move this thing. Let's go to Stat, Edit. I don't have those in there, but let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it 11?
Yeah.
And then,
Here you go.
no, I can get it. Hold on, thank you. Okay. Here we go. 49, 58, 66, 72, 76, 79, 80, 80. Oops. 80, 80. Make sure I can get 78, 74. And 69, 62. 69, 62. Now, go to, you got to do a stat plot. So hit second, y is equal, and then turn your stat plot on. And you want a scatter plot, which it automatically defaults to scatter plot, and then hit enter, and then graph. Well, sorry, you got to go. Okay, there. Why ain't it moving? Okay. Now graph. There. And go to zoom stat, which is 9, I think. All right. Now, what do you see there? Do you see a straight line?
No.
No. You see a what?
Parabola.
Parabola. You see a polynomial. So you go to second, or go to stat, calculate, and then you go down to quadratic, and you hit enter, and L1, comma, L2, and enter, and write that information down. Now that's how you do it on the calculator. Now I'll tell y'all what all this means in just a minute. Yeah, you got second 1, comma, second 2.
I got a second.
Yeah, well, yeah, it defaults. It will default to L1 and L2. If you put anything in L3 and L4, you have to tell it. Okay, so write that information down or keep it on your calculator. What you've got is ax squared plus bx plus c. Now, what is that? Well, you see it better on the handy dandy. Is this it? Yeah, is that it? I think it is. All right. There is the and you just click on that right here, and you hit Format Trendline. For those Excel people, you right click on your point, and you hit Format Trendline, and it'll go to polynomial, or you'll have to tell it to go to polynomial. Because sometimes it may be logarithmic, some days it may be exponential, okay, depending on what it looks like. Now, that dotted line right there is your regression curve. That is the best line. Now, this one does, but let me look, if you can, look right here. Is this point right on it? Not really, is it? See, there's some points that fit it. This point doesn't fit it. This point's a little bit over. This, you got some points that are not right on it. So that dotted line is a regression fit curve. Now, what can you do there? Well, you can find the slope from this point to this point, or this point to this point. Or you can say, okay, let's take the derivative. Y is equal to negative 0.8039x squared plus 10.03x plus 48.953 plus 48.953. All right, take the derivative. Somebody take 2 and multiply by 0.809. What do you get? One point what?
6.8.
And what is this? That's the equation for what? For the slope at where? At any what? At any point. Where if you look at the algebraic right here, you would have to do what? You have to use those 2 points, 2 points. You'd have to use these 2 points or these 2 points, and you'd have to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if you wanted to find a point at any point, you would have to do how many calculations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But what if you wanted to find the slope at this point right here? What if you wanted to find the slope right here? Well, you would have to interpolate and actually find that point, and then take one of the other 2 points and use your algebra to do that. Or you could just say that's 8 point what? Well, this is 9. That's right. So that would be what, 8.2 maybe? At 8.2, negative 1.6078 times 8.2 plus 10.036. Somebody calculate that out for me. Tell me what number you get. It's not going to be negative. Because negative, it shouldn't be, because, yeah, I'm sorry. What would it be? Negative what? 3.14, well, 3.15. So the slope right here, right there, is 3.15 over 1. 3.15 over what? 1, and it's negative, which means left to right down. Now, if you wanted to find the point here, that's 0.2. So somebody take negative 1.6078 times 0.2 and add it to 10.036. What do you get? So the slope here is 9.71 over 1 at that point. So And that is the, now remember, is this the actual line or is this the line of best fit?
That's it.
It's the line of best fit. Because if you actually had the line would not be a pristine parabola. It would be kind of jagged. So that's why you have to use the line of regression. Okay, I'm trying to get y'all to see where this is going, okay? So just bear with me because I'm not real keen on doing this, but that's what they want to do in this book. So let's pull up another example. So let's take this example. Or not this example, but another one. Y'all don't get too excited. Let's go with this one. Get rid of all that junk. All right, put those points in. And see if you can do it on a calculator. As long as you can do it on a calculator or the Excel spreadsheet, you're good. And you got to know what you're doing. If you don't know what you're doing, then it defeats the purpose, because where we're going with this is we're going to put the algebra to the back. We're going to put it to the back shelf and start using calculus to find the slope. Or, I'm sorry, the rate of change. Got to get our words right. So, let's take the first derivative. Y is equal to 0.6818x squared minus 3.6711x plus 10.47. Now, the reason I'm not worried about the 10.47 is what's going to happen when we take the derivative to 10.47. It's going to go away. Y prime, somebody take 2 and multiply it by 0.6818.
1.3636.
1.3636 x minus 3.6711. So that is our equation, and you need to write that over and over and over. This is the equation for the slope at any what?
Point.
At any point. So now I've taken, now see this you can see better. Look at these points. Are these points exactly on the regression line? No.
No.
That dotted line is a line that is best fit. Now, where do you see this being used? Where do you see it being used? What's your major? Most of y'all's majors is what?
Business.
Business. Why would you use a best fit line instead of going from point to point to point? What do you want to be able to do in business? P, R, E, D, I, D.
Predict. 3 people have already said it.
You want to be able to predict. So that leads us to extrapolation and what? Interpolation. Extrapolation means I can extend this line up here at 10 whatevers. What is this? It doesn't say. It's in your book. I think it's the first example. 10 hours, at 10 hours or 10 days or 10 years, I'll be at 30, about 40, whatever that unit is over there. So I extrapolated, I extended the line to predict. Now, what is interpolation? What does I and T mean?
Inside.
Internal. Internal prediction. Internal prediction means that, well, I've got 6 and 7, but what about 6.5? Or 6 whatever, 6.5. What is that? 6.5 is going to give us 15. Okay? So not only can you tell the equation for the slope using calculus, you can also use the regression curve for, and if you look, it's not going to be able, you're not going to be able to do a prediction when your points are jagged. I like your teeth. You know, you don't want your teeth to be jagged. Well, you don't want your parabola to be jagged either, because that doesn't give you a good predictor. Okay? So that's where this is going. And if you want to condense it, and sometimes this helps. Let's see. This is what you're doing. All right? 1, you've learned the algebra. Then you're basically putting regression in here. Okay? You've done the algebra. You've done the algebra review. You're capping on regression because you want to be able to get a line in there that best fits the data so you can predict. At the same time, you want to be able to start using your calculus to find the slope at any point. At any point. So we can start finding things in Unit 3 and 4 pertaining to the calculus, because, you know, at any point on a curve, when you find the point, you've got the tangent line. So therefore, you can find the normal vector also. And that normal vector means something also. And you have several other vectors you can get after that. So that's where regression is going. Now, I ask you to be patient. What I'm going to do this weekend is I'm going to go ahead and I'm going to put all the homework up. 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. We're not going to spend a lot of time on chapter 2, okay? Because we need calculus, all right? So I'm going to go ahead and put that up this weekend, and I want y'all to go ahead and work it. I want y'all to go start sending questions in on chapter 2 for Tuesday's class. And I want to get through. I want to get this regression thing, because they're right here. I want to get this out of the way.
So everything we just did that's all Unit 2 is?
Yeah, in some way or another. I mean, I'm going to cover Tuesday. For those that have questions, I'm going to take those questions and I'm going to integrate it into lessons if you need it. But a lot of chapter 2 is kind of repetitive. It's repetitive, and also, did y'all see how long the lesson was on 2.1? It was 2 examples, maybe 3. So you're talking 2 examples per. You're talking about 8 problems, or 9 problems, or 10 problems. So you're not really talking about a lot of material, okay? All right. I want y'all to get out of here, have a good weekend, and anybody got questions, challenge questions for the tests, stay around after class. I'm going to turn the recorder off, okay? And I'll put up the homework.